Hi ladies, in this video we're going to go through the solutions for the probability test. So the first 15 marks were multiple choice, so I might just quickly scroll down. If you need to have a look at any of the answers, just pause, but we're going to go through all the questions anyway. Okay, the multiple choice was done quite well. The whole test was done quite well, in fact. Question 3, I think, with a tree diagram stumped quite a few people in the extended response. But let's go through all the multiple choice questions. So I don't have the working out for the multiple choice, so I'll do the working out or the explanation as we go. So question 1, a box contains 6 red blocks, 5 yellow blocks, and 4 green blocks. What is the probability of selecting a red or a green? So how many blocks do we have in total? We have 15. And how many of them are red or green? So we have 6 red and 4 green. So 10 over 15, which gives you 2/3. So the correct answer for that one was D. Question 2, for this two-way table, the probability of A and not B. So we want A and not B. We want the number that goes in here. Okay, so that's how you read a two-way table. But this two-way table is incomplete, so we just need to fill it in. So you just look at your rows and columns, so they all need to add up. So 3 plus 4 gives you 7 here. And going across this bottom row, that must mean this is a 3. And this column here for A makes that a 1. You don't really need to fill in the other ones, but I'll just do it anyway. So moving across this first row for B, that's going to be a 1. So 2 plus 1 equals 3. And then not B, 1 plus 3 gives you 4. And all these numbers in the middle for cells, okay, so these cells here all have to add up to the total, which is 7. So that's good. So the probability is 1 over 7. So the correct answer for that one is C. All right, a letter is randomly selected from the word congratulations. The probability of selecting this letter is 2 over 15. This letter could not be. So I'm assuming there's 15 letters in congratulations. You can count them if you like. So basically we're saying, well, what letter doesn't occur twice? Okay, so the letter O does occur twice, A occurs twice, N occurs twice, T occurs twice, and S only occurs once on the end. So the probability of getting an S is actually 1 over 15, whereas the other letters is 2 over 15. All right, question 4. In a standard deck of playing cards, 0.25 is the probability of selecting. So you can go through and do the probability of each. So a black card is going to be a half. A spade is going to be a quarter. Okay, so there's our answer. So 0.25 is the same as a quarter, but I'll do the rest anyway. A queen, you have 4 in a pack, so that simplifies to 1 over 13. An ace of diamonds, there's only one of them, so it's going to be 1 over 52. And a red queen, there's 2 of them, so it's going to be 2 over 52 or 1 over 26. So the correct answer for that one is B. All right, question 5. The following Venn diagram represents the events football and netball. 3/5 represents the probability of. Okay, so again, we're going to have to go through all of them. So in total, we'll just count up how many people we have. So 25, 10, 10, and 5 gives you 50. So the probability of F is going to be 35 over 50. So we want 3/5. So basically, we're going to get 30 over 50, I would say. F and N is this intersection, so that's 10 over 50. You can simplify them, but I'm going to work quicker if I don't simplify. Not N, so that's going to be the 25 and the 5. So that looks like it's going to be our correct answer, 30 over 50, because that simplifies to 3/5. But let's just do the other two anyway. Not F and not N. So that's 5 on the end there. And then probability of n is 20 over 50. So the correct answer for that one, which we said before, is C. All right, question 6. Which one of the following is an example of mutually exclusive events? So remember, mutually exclusive events have nothing in common. So if you drew them on the Venn diagram, they look like that. Girls, I'm noticing with Venn diagrams, you are putting your rectangle around. So please make sure you put your Venn diagram around, your rectangle around your Venn diagram. Okay, so there's no intersection. So they have nothing in common. Okay, so numbers divisible by 4 and even numbers. So every number that is divisible by 4 is also even. So they're definitely not mutually exclusive. Prime numbers and odd numbers. So the prime number 7 is odd, so they're not mutually exclusive. Numbers divisible by 2 and odd numbers. Okay, so all odd numbers aren't divisible by 2, so that's going to be C. Let's just check the others. Even numbers and numbers divisible by 6. So if it's divisible by 6, it's definitely even. And because 6 is also even. And numbers divisible by 7 and even numbers. So the number 14 is divisible by 7 and is also even. So the correct answer for that one is C. All right, question 7. So question 7, there was a little bit of an error, and I thank girls for picking that up, but we're just going to use the addition rule to do this. So the addition rule is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So this is just your addition rule. 0.3, probability of A is 0.2 plus 0.4. And probability of A and B is what we're after, so you can just call that X. So we're just solving for X basically. So we've got 0.3 equals 0.6 minus X, so that makes X equal 0.3. Okay, question 8. For this Venn diagram, the probability of A given B. So this is a conditional probability formula. So probability of A given B is equal to the probability of A and B over the probability of B. I'm really worried Word is going to shut down on me because see how it's, oh well, you probably can't see my arrow, but it's glitching. Okay, so we've got probability of A and B is 5 over the probability of B is 7. So the correct answer for that one is A. All right, question 9. In a standard deck of playing cards, the probability of obtaining a card that is either diamond or queen is determined by. So this is a, we're looking for the union. So you use your addition rule. Let me just, diamond or a queen. So diamond or queen. So it's the probability of a diamond plus probability of a queen minus the probability of a diamond and a queen. Okay, so the probability of a diamond is, it's gone blank, 1/4. Probability of a queen is 1/13. So we're, oh, yes, sorry, 1/13 minus diamond and a queen. So we've only got one queen of diamonds, so it's minus 1/52. So the correct answer for that one should be D. That's around the other way. Okay. Question 10. A box has 10 red and 5 blue counters. If a red counter is selected and replaced, then the probability of selecting another counter is. So this is an example of independent events. So selecting a red counter doesn't depend on its previous probability. So a box has 10 red and 5 blue counters. So we've got 15 in total. And we want a red. So, oops, sorry, looking at the wrong number. 10 over 15. So the answer for that one is 2/3. So that's an example of independent events. Question 11. A number is chosen from the first 36 positive integers. So an integer is just a whole number, and positive just means it's greater than 0. The probability that the number is divisible by 6, given that it is divisible by 3, is. So numbers divisible by 6. So we're looking at the first 36 numbers. So we've got 6, 12, 18, 24, 30, and 36. Given that the number is also divisible by 3, so we've got, you can do all of them if you like, but you don't need to. Takes a while, and I'm really concerned about my glitchy computer. Okay, so there they are. Now this is a conditional probability question. So if I set it up, the probability that it is divisible by 6, so divisible by 6, given that it is divisible by 3. So we want the probability that it is divisible by 6 and divisible by 3 over the probability that it's divisible by 3. Okay, and I always write the probabilities, but I should be writing n, just a number. Okay, so 6 and 3. All these numbers, in the top line, are also divisible by 3. So we've got 1, 1, 2, 3, 4, 5, 6. And then the probability that it's divisible by 3, well, I'm just counting. I know you can't see my mouse. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the probability is a half. So the answer for that one is E. You don't need to write these out, okay, but sometimes it helps to show what we're actually talking about. Okay, question 12. A card is drawn from a standard deck of 52 playing cards. Find the probability that the card is a heart, given that it is a queen. So the probability of a heart, given that it's a queen. I saw someone draw a heart. I thought that was quite cute. Okay, so we've got the probability of a heart and a queen. Now I wish I had drawn a heart. Probability of a queen. Okay, so how many cards are queen of hearts? So we have 1. How many queens? We have 4. So for that one, it is D. Question 13. In a group of 20 students, 8 study maths, 10 study chemistry, and 4 study both maths and chemistry. Okay, so you can draw this on a Venn diagram. Don't forget your rectangle. Okay, and we've got maths and chemistry. Now, always start with how many study both. So 4 study both. 8 study maths. So 4 of them already study both. So that means 4 just study maths. And in the 10 that study chemistry, 4 study both. So that leaves 6 with just chemistry. And then we've got to work out how many study neither. So I've got 14 there. So that means 6 on the outside. What fraction of the people who study maths also study chemistry? So this is a conditional probability question. So the probability that, oh no, sorry, it's not. It's a union. I read that question incorrectly. What fraction of the people who study maths also study chemistry? Oh no, it's a conditional probability question. Yeah, because we're only looking at the people who study maths. So that's me not reading the question correctly. Okay, so we want chemistry, given that they study maths. Okay, so probability of both, or the number of both, and the number who study maths. So we're just looking at this math circle. I might just highlight it. Okay, so we're just looking at the number who study maths. How many study both is 4. How many study maths is 8. So that's a half. So the correct answer for that one is C. All right, question 14. So here we have A given B, probability of B is 0.5, the value of A and B. Okay, so we use the conditional probability formula, which is this. All right, so A given B is 0.4. A and B is what we're looking for, so I'll just call that X, and probability of B is 0.5. So X is equal to, if I just solve this, multiply both sides by 0.5. So 0.5 times 0.4 gives you 0.2. So the correct answer for that one is B. And last multiple choice question. The probability of two events, K and M, are partially displayed in the following two-way table. The two events are mutually exclusive, and we've got to find the probability of not K and not M. So we want the value that goes in here. Now, the trick with this question is I've only given you two probabilities, but I know that all the probabilities have to add up to 1, so I put 1 there. And they've also told me that they're mutually exclusive, so that means that has to be 0. And then I can fill in my table. So going across here, this has to be 0.2, okay, because the row adds to 0.2. This has to be 0.3 because the column has to add to 0.3, which makes this 0.7. And here 0.8. I probably could have worked this out before, but it's 0.5 there. So filling in that table just meant you had to know that mutually exclusive events, you put the 0 in and the 1 for the total probability. All right, let's move on to the extended response question. So for question 1, it was done quite well. Venn diagram, I can't think of anyone who got that one wrong. Just remember we're looking at the probability, so all your answers should be either fractions or decimals. Some people write decimals, but I would rather you just leave the answer in fractions because that's your exact form. If you were to write 1/3 as a decimal, you're writing 0.33, which would be recurring, which isn't exact, okay? So just keep it as a fraction unless it asks you to round to decimal places, or unless it's like a quarter and you don't need to do any rounding because it's just 0.25. All right, so student likes football but does not like dancing. So that means we're just looking at likes football but does not like dancing. So 10, we're just looking at the 10, not the intersection. So 10 over 30. What is the probability a student does not like dancing or football? So that's on the outside, so the 5, so 5 over 30. And what is the probability that a student likes dancing given that they like football? So we're looking at the football circle. I'm actually drawing this or highlighting it and then not realizing it. So we're just looking at this circle here. So it's the intersection over everything. So 10 over 20, which gives you 1/2. I wonder if I can get rid of this. So I wanted to keep my solutions. There we go. I'll just go over it again. Okay. Moving on to the next question. So question 2, part A was done fine. I think there was one person who wrote an incorrect number in one spot, and I think I just gave you the full marks because it was just a small error. But that was done well. I think having these numbers already done for you was of help. Find the probability that the product of the two dice is an odd number. So you just count up how many odd numbers there are, and there's 9. So 9 over 36, which gives you 1/4. Calculate the probability that the product of the two dice is odd, given that the blue die showed an odd number, so it's the same thing. We're only looking at the columns 1, 3, and 5, and which ones in them have odd numbers, but that's pretty much the same thing as question B. And calculate the probability that the product of the two dice is at least 10, given that the red die was a 6. So we're only looking at the row with the 6. Okay, so how many numbers are there in that row. So there's 6 numbers, and how many of them are at least 10? And there's 5, so it's 5 over 5 over 6. All right, and question 3 was probably the most difficult with the tree diagram. So basically, we're looking at 2 events, okay, and those events were given to you. So event A is Ashton is selected, and event not A is Ashton is not selected for captain or vice captain. So Ashton can't be both captain and vice captain. Some people were doing captain, vice captain, and then not Ashton or Ashton. But basically, we're looking at our first step being captain. So if I put that there, and then this is vice captain. Okay, so Ashton can either be captain or not captain. And you can have your VC and your C around the other way as well. And then the second step is vice captain. Now, the probability of Ashton getting captain is 1 in 20. Okay, there's 20 students and he's just one of them. Therefore, the probability of him not being captain is 19 over 20. So there's 19 other students who could be captain. So the probability of it not being Ashton is 19 over 20. Now, if Ashton becomes captain, the probability of him being vice captain is 0. He can't be both. So 0 over 19. The probability then of him not being vice captain, so if he was already captain, the probability of him not being vice captain is 1, so 19 over 19. If we go to the second branch, so here, not captain, okay, so therefore he can become vice captain. If he doesn't get captain, he can become vice captain. The probability is then 1 over 19. So one student, let's call her a girl, Vanessa. So Vanessa's already captain, but, you know, Ashton can become vice captain. And the probability of him not being vice captain is 18 out of 19. So, you know, he could become vice captain, but it's highly probable that he won't be. Now, with your outcomes, the first outcome is Ashton is both captain and vice captain. The probability of that is 0. It can't happen. He can't be both. The second possibility, Ashton is captain but not vice captain. It's 1 over 20. Ashton is not captain but vice captain is also 1 over 20. And Ashton is neither is 18 over 20 or 9 over 10. Which I didn't simplify that before. I don't tend to simplify these, but I did notice some people simplified it to 9 over 10. Just with these fractions, girls, you were allowed to use your calculator, but you can easily do these fractions because, actually I might move to this one. This 19 cancels with this 19, which leaves you with 1 over 20. And this 19 cancels with this 19, which leaves you with 18 over 20. So when you go into methods, your skills with fractions and decimals, you're going to have to freshen up on them, especially decimals. You'll probably have to teach yourself again how to multiply decimals. All right, question B, what is the probability Ashton will be selected as either captain or vice captain? So I'm just adding up the 2 possibilities. So 1 over 20, so here and here, 1 over 20 and 1 over 20. So 2 over 20, which is 1 over 10. Now, if you got your tree diagram incorrect, but you wrote your probabilities, I would have given you consequential marks. So if I ticked this and it's wrong, it's because I gave you consequential marks based on your incorrect tree diagram. Now, question C, you had to explain. Okay, so I did my best to explain. I allowed a variety of different answers, but basically the probabilities aren't independent, or they're not independent, because we're doing without replacement, basically. So it's not like we're in the sense of replacing a marble in a bag, but the probability of the first event changes the probability of the second event. Okay, because once the captain is chosen, that person isn't put back in. So it's without replacement. So if you put without replacement somewhere, or you said that the probability is dependent on the previous outcome, or it doesn't affect the outcome. Okay, I had some great explanations, but if you just gave me a calculation like I've got in D, then that's not explaining, that's showing. So make sure when it says explain, you relate to the definition of independent events or whatever it is in the context of your problem. Okay, and then question D, just using the two formulas for independent events and showing that they're not equal, therefore they're not independent. All right, girls. Bye.